What's up, everybody? This is Eddie, and welcome to Techniks Toool Group Live, an interactive and engaging demonstration where we're going to help you maximize your capability and turbocharge your machining. Now, remember, with this being an interactive and engaging demo, we not only encourage, but we anticipate each and every one of you to leave any questions or comments that you may have in our chat box on this section of the screen. But please remember, if you do want to hop into that chat box, you do need to be logged into your YouTube account. So get logged in, hop on in that chat box, and you never know, we may be able to take your question or comment and pull it up on the screen and answer it in real time with one of our industry leading experts. So we're really excited today, but following our demo, make sure you head on over to Techniks YouTube page. I need you to hit that subscribe button, ring the bell to turn on the notifications so we can keep you in the loop with all the amazing content. And last but certainly not least, give us a huge thumbs up. We'd greatly appreciate it. So for today's demo, we're going to be utilizing a variety of tools, machines, and processes. And to provide even more convenience and value to all you viewers out there, we have not one, not two, but three industry leading experts to provide an immense amount of value in their respective sections. So let's get things rolling here, and let's introduce those who are going to be working with us today. As always, on this section of the screen, I got my right hand man, our master of machinists and our in-house specialist, Aaron. Hey, how you doing? You ready to make some chips today?
Absolutely. We got a lot of great products and some experts that really know what they're talking about, and it's going to be some fun.
There we go, there we go. So aside from Aaron, let's bring on our industry leading experts. First, we're going to be introducing our friend Mike MacArthur from the team there at RobbJack. So let's get him up on the screen here. Hey, Mike, hey, thank you so much for joining us today. We're really excited to hear some of the amazing things you're going to be sharing with us. But before we get started, why don't you tell all of our viewers who you are and what you do over there at RobbJack?
Thanks. My name is Mike MacArthur. I'm VP of Engineering at RobbJack. I've worked there for over 25 years. Started as a tool grinder, worked my way through the shop. Now lead our team in research and development, as well as technical sales. So I want to thank the Flex team, Techniks Group, for including me in this presentation, and I look forward to it. Thanks.
Hey, right on. We appreciate you joining us today. Excited to hear some of the value that you're going to be providing in the stream. So let's bring in our second industry leading expert from the Techniks team, our good friend Mike Enix. Let's pull Mike up on the screen. Hey, Mike, hey, thank you so much for joining us, man. It's always a pleasure. So again, for our viewers, tell us a little bit about Mike and what you do for Techniks.
Hey, Eddie. Mike Enix. I'm the VP of Sales for Techniks Toool Group. Techniks Toool Group is comprised of two great brands, both Techniks as well as Parlec. And we've been working really hard. Actually, our R&D and engineering departments have been hard at work introducing new high-performance tool holding solutions. And we're super excited to show those to you guys today.
No, very good, very good. Hey, we appreciate you taking some time to provide some value for this demonstration. So appreciate it, excited to see what you got for us. And lastly, we're gonna bring in our third and final expert, Brian. Hey, let's get Brian up on the screen here. Hey, Brian, we really appreciate you joining us, man. As always, you know the style. Tell us a little bit about you and what you do for Techniks.
Hey, Eddie, how you doing? Greatly appreciate being here as well. My name is Brian Haskett. I am one of the national sales guys with Techniks Toool Group. Been there for quite a number of years, pushing 15, and I'm really excited today to sit here and talk with you and Aaron about these exciting tools.
Now, hey, exciting indeed, man. So we appreciate you joining us. And with that being said, it sounds like the gang is all here. The stage is set. Let's get some things rolling. So Aaron, what are we starting with today, man?
Yeah, so the first thing that we're going to start with is over here on the ShrinkSTATION 450 machine. It's the ShrinkFIT machine from Techniks. And I know, Brian, you're going to start us off here. So kind of give us a rundown of what this machine is capable of and some of the options that come with it.
Yeah, so what you're looking at there is our ShrinkSTATION unit. So this is what you have on the table there is our 00450 unit. That unit there is a three-phase 480-volt unit. We do make this model in a 220 single-phase unit for those who have that power option in their shop. The good thing, one of the big things about our machine, it is made in the United States. We make it in Indianapolis, Indiana. And this is a very automated and automatic design. As you can see there, that PLC as they zoom by there. Everything's preset. It's all touch screen, drop down menu. The ease of use is extremely easy. So like I said, that is one of the models. We do have a few other models that we can speak of down the road here. But as you can see, as they're running through the B-roll there, it's just simply slide bar and push button. Everything's preset into it. So you can just drop it down as he sees there. He's at 12 millimeters, and he can move the slide bar up and down if he needs to add more time.
This looks good, so it seems like it's relatively easy to use, but Brian, tell us this. How does your ShrinkSTATION 450 stack up against the competition?
Yeah, so the biggest differentiator in the competition is, first off, we're American made. So a good thing about our units, we control all the design and building of them in Indianapolis. So it allows us to not have to wait for weeks on end to get parts shipped over from, overseas. We can do everything, control everything from new design to changing little components to figuring out new and better ways to improve upon this machine.
Absolutely, absolutely, man. And then to that, what are some of the standard items that this machine comes with? And then do you have any additional options for those contingency plans that may be needed with your specific customers?
Yeah, most definitely. So with our machine, you're going to get the 4 different size ferrite rings, which are, we call them the induction rings, that keeps the head, those right there, that keeps the head down into the actual coil itself. You're going to get 4 different sizes for those that range everywhere from your 4 millimeters up to your 1.5 inches. And then you're also going to get 3 different adapter plates that right there, the spindle adapter plates that are going to allow you to go from your BT40 to an ISO to even the HSK 100s. So that, and then you're also going to get a thermal glove to keep that hand, excuse me, nice and cold so you're not burning yourself when you're inserting and installing those tools.
Okay, so a couple of different options you can cater to the specific customer. That's awesome. Now, what about when it comes to shrinking longer tools?
Yeah, most definitely. So that machine that you're looking at there, believe it or not, can handle up to a 22-inch tool. So we do have a what I'm going to call a added pedestal extension that would screw on to the base, and it would allow you to get a little bit more stroke out of that machine. Again, allow us to handle up to 22-inch tools.
There we go. There we go. So with that, man, hey, we ready to see this thing kind of in action, or what are we doing?
Yeah, absolutely. So I got the Cat 40 tool set up in here, and I've got a 1/2 inch tool that we're gonna shrink. I've already got the settings, kind of like what Brian was talking about. Everything was touchscreen, so I have everything set and ready to go. So I'm gonna just click a single button here, and the tool is gonna come up. Brian, just go ahead and give us kind of a rundown of what we're seeing here.
Yeah, so that auto up option, it's going to go all the way up, and it's going to touch itself off to that ferrite ring. And it's going to recess itself just to put enough gap between that ring and the tool holder itself to not create a short through our induction head. And it does that automatically for you. Once it's done, it'll stop. It's letting you know you're ready to go ahead and hit the heat button and get ready to insert your tool.
So I've went ahead and inserted the tool in here. Now, Brian, I know we're going to hear some air. Here we go. So what's happening here?
So as you can see there, that was the head air. So that comes on, and that's going to use standard 90 PSI shop air. And that, as you can see it stroking up and down, that is going to make sure with that 6-inch gauge extension there, we're going to make sure that we're cooling the actual taper itself evenly. It will do that for about 2.5 to 3 minutes, and then that tool will be cool enough using just shop air to go back into your spindle.
Very good, very good. We'll see you pull up a little bit of B-roll here to see this even more so in action. Now it looks good. Now is this what we're looking at when it comes to standard operation of this machine, Brian, or is this what we're looking to expect?
Yeah, like I said, this machine is extremely easy. It comes with a full manual, as well as, like I said, everything's automated here. So we set all the parameters in the PCL. It's programmed by our engineers, and then when you get it, it's a simply touch down, drop, push a button. It's very, very simple. We do have an audit trail in there that can keep track of how many times that you have shrunk a tool in. It's kind of like a cycle count, if you will. But yeah, as far as ease of use, this machine here, as far as the market goes, easiest machine to use out there.
Yeah, the ease of use seems like the setup's easy. It's not this large, huge machine by any means, but you can handle a variety of different types of sizes of tools. And you have not only standard options, but you can cater to the different types of applications. So am I hitting upon all the good things that are really to have when it comes to the ShrinkSTATION 450?
Yeah, definitely. I mean, the only other thing I want to hit on the ShrinkSTATION is, this is our small tabletop unit. This is a great one. As you can see here, it's in this cell. Aaron's able to use this as he breaks or dulls tools. He can be right there using it. We also offer 2 different size units that are going to be larger than this one. Those 2 units are 483 phase only. We do have the Shrink Pro, which is going to be a little bit larger. It's still a tabletop unit. And then we also have what we call our quencher machine. So if the 2.5–3 minutes of air cooling time is going to be an issue, we do happen to have a machine that's a little bit larger, takes up a little bit bigger footprint, but it's going to allow you to actually shrink a tool in, go down to a coolant bath, present itself up in 30 seconds, and you're ready to go back into the spindle.
There we go. Even more options on this specific technology. Love hearing it. And thank you so much for bringing your expertise and all that insight to this specific machine. So, hey, is there anything else that we're looking here on this specific segment? Are we ready to roll on?
Now we're ready to roll on to we just showed the ShrinkFIT machine. Now we're going to talk about the ShrinkFIT holders, and we're going to bring in Mike Enix to kind of give us the rundown on what we can expect with the ShrinkFIT holders.
There we go. We'll bring Mike Enix in. Hey, man, give us the good news. Tell us about these standard ShrinkFIT holders, Mike.
Yeah, so, really the benefit of ShrinkFIT is a couple things, Eddie, for our audience that may not be familiar with that technology. So with ShrinkFIT, you're holding the cutting tool with very solid H13 material. So from an accuracy and a rigidity standpoint, there's really no better system on the market. Our standard ShrinkFIT offering is available both in the Techniks as well as the Parlec offering. And we're very proud of the fact that our Parlec brand is made right here in the United States in Fairport, New York. In both brands, we'll use certified H13 steel, balanced to 25,000 RPMs at G2.5. So in terms of quality, really second to none. The Parlec offering actually matches popular industry standards in terms of the nose dimensions and the gauge lengths. So in terms of changing out from one system to the next, the Parlec is going to be plug and play relative to not having to reprogram any machines.
Yeah, absolutely. And I think we've got a little bit of B-roll we want to pull up as well as we're kind of talking through this to see how good this looks.
Yeah, Eddie. So if you want to bring up the coolant ported holder, so the Parlec offering as well as the Techniks offering is also available with coolant ports. So the coolant ported holders are going to direct coolant right to the cutting zone. That's going to flush away all the chips and allow you to feed the tool faster. It's also obviously going to extend cutting tool life. So the coolant ported option is great for those folks that are really wanting to pour the coals to the machining process and really remove a ton of material.
Yeah, no, it looks great. It looks really good. Yeah, for sure.
Yeah. So Eddie, we also have our modular system, which I think we wanted to show maybe a close-up of that with Aaron. But our modular SFS system is fantastic in that it has a master holder and then a variety of different extensions. So these extensions are available in a bunch of different diameters, both inch as well as metric. And then the adapter that you see there is available in 4 different gauge lengths. So the benefit of this is obviously you see the nose diameter is very, very narrow and small. So if you're doing 5-axis machining, if you're trying to get down inside of a pocket or around a fixture, the SFS system is great in that regard.
Now that looks good. Now let's scoot over a little bit. Let's get more of the insight on this heavier wall type of holder. So you want to give us a little bit of what you can tell us about this specific item here.
Yeah, so Aaron, if you could show the heavy wall holder. So we also offer a what we call a heavy wall or a thick wall ShrinkFIT holder. So it's gonna have a larger nose diameter, and this is for very, very heavy metal removal. So a ton of side load. It's got a longer bore engagement with the shank of the tool, so to make sure that the cutting tool does not slip from the holder. But really that extra mass or that extra beef at the nose of the holder is going to allow for heavy feed rates without that tool slipping.
And so when it comes down to it, we've gone over a lot of different benefits of that type of style. Mike, tell me, who needs this?
Yeah, so the heavy wall, Eddie, is really used in aerospace. So we have some household names in aerospace manufacturing that would utilize these tools. In fact, we've made a ton of the heavy wall holders, both coolant ported, different gauge lengths. They have very specific requirements in terms of the number of coolant ports, how long they want the holder to be, how much bore engagement. So when you think about specials, if you don't see something in the catalog, for sure, our heavy wall would kind of fit inside of that, what we call our turbo turn division. So if you don't see something in one of our Techniks or our Parlec catalogs, our Parlec facility, our Rochester facility in New York, is uniquely equipped to make specials in as fast as 5 weeks. So we have a ton of different styles and types of tool holders that we can make that are in our turbo turn division or our specials division.
Yeah, very, very impressive. And as we continue to talk about, some of these additional items, why don't you tell us a little bit about Shrink Locked? We got to hear more.
Yeah, so Shrink Locked is an insurance policy, Eddie. So again, in these very strict applications where somebody is working on an extremely expensive part and they just absolutely cannot afford to have a tool slip or spin inside of the tool holder, we make our Shrink Locked system. So this is guaranteed to never slip or spin a tool. In fact, in our testing of Shrink Locked, we have never reached the failure point of Shrink Locked. So the only thing we've ever been able to do is stall a machine spindle or break a 3/4 inch carbide pin. So the way this works is we apply a patented compound that we call TTG 594. So it's embedded into the bore of the tool holder. It does not affect the ability to shrink the tool in and out, nor does it affect the shrink times required to get a tool in and out of the system. So if you're absolutely want an insurance policy that you cannot have a tool slip, Shrink Locked is the way to go. The beautiful thing about this, it requires no modifications to the tool shank, unlike some of our competitor systems out there where you have to modify the tool shank. Our shank, the shank of the cutting tool, does not need to be modified in this case.
Gotcha. And then lastly, before we take this specific holder and then put that RobbJack tool into play, tell us a little bit about turbo turn.
Yeah, Eddie, so turbo turn is out of our Fairport facility. Yeah, this is a good sampling of some of the different tools that you see. So we really specialize in specials. So if you don't see something in the catalog that you need, or you want to just optimize that application, so maybe 8-inch gauge length is not what you want. You want a 9.5-inch gauge length. We do this type of work all the time, and we are absolutely set up to do this here in the United States, which we think is a huge advantage. Most of our competitors are manufacturing tool holders overseas and just cannot meet the lead times that we can in our specials department.
Yeah, no, sounds impressive, and a lot of great insight there about these ShrinkFIT holders. So now we're going to toss it back up to Aaron. So hey, what is next in our demonstration?
Yeah, so we're going to take about the awesome tools that we just talked about, the ShrinkFIT holder, and we're going to get it in the machine. Before I actually start the cycle, we're going to bring in Mike from RobbJack to talk about the end mill that we're going to put in this ShrinkFIT holder and what the benefits are to the chatter reduction geometry that comes with these tools. So Mike, go ahead and take it away. And I know we have some B-roll footage of some what bad chatter might look or sound like. If you could kind of just give us the rundown of what we're going to be looking at.
Thanks, Aaron. So on this first demonstration, what you're looking at is we're going to be creating a 30 thousandths thick wall, 1.5 inches tall. And as it starts to cut, you'll be able to hear the vibration and chatter. And when you're cutting with the tool and you see it, and the vibration is the cutting tool and the part is cutting out of sync. So that vibration of the part and the tool excite each other. So later on in the presentation, you'll be able to go and see the finishes, and there's going to be a dramatic difference between this ER style holder versus the ShrinkFIT style holder that we're going to do in the next live demonstration, and versus mirror edge geometry that gets rid of the chatter and vibration.
Yeah, so I'll go ahead and get the program started here. And Mike, again, kind of give us a rundown on what we're seeing with not only just your tool, but how the tool reacts with the holder and the reduction of the chatter that you were just talking about.
So on that last demonstration, I don't know if you were able to hear the sound, but as this goes and cuts and you listen to it, it'll be nice, smooth cutting. You won't hear the vibration and chatter. You'll be able to see the difference in the finish. And what this is with the rigidity of the ShrinkFIT holder, in conjunction with RobbJack's patented mirror edge geometry that makes the vibration of the tool and the vibration of the part match, we're able to make them dance in unison. So as they're vibrating in unison, it really gets rid of that chatter and vibration. So that 30 thousandths thin wall part sticking up 1.5 inches with no support, it's unsupported, it's no ribs or anything connected to it. We're able to cut that part along with the ShrinkFIT technology and that added gripping force. We also put technology into the tool. So we have anti-pull-out shank technology on all of our tools that adds about 70% gripping force. Because with tools that are used in this type of application, really the only limiting factor is your machine. So we're able to machine aluminum and remove about 80 pounds of aluminum per minute in some of the larger machines. And so you're really the only limiting factor is your horsepower and RPM on the machine when you have this type of holder and this type of tool.
Well, one question I may have, and it may seem like an easy question to you, Mike, but for those who are hitting cycle start, for those who are really at the spindle, why is it so important to be so aware of the chatter that's happening at the spindle?
Whenever you have chatter or vibration, you really don't have a reliable operation. You can run into inconsistencies in tool life. You obviously, what we'll see as Aaron pulls out the parts and look at the differences in finish, you'll see the difference in the finish of the part. So it can get rid of like post-operation procedures like hand finishing, benching, all this manual work that really causes issues. You can have a tool come off or a part come off the machine and it's done. There's no chatter, no vibration. So not having that chatter in the part is really important.
Well, hey, we keep talking about it. Now let's get a quick visual. We have two of these finished parts here. First, we're going to show a close-up view of what it looks like when we get a little bit of chatter here. So we can get a quick view. Tell us what we're looking at here. This is the chatter piece.
Yeah, so what you're seeing is all those rough finishes, the mismatches. It's actually digging into the part where it shouldn't be, and you really don't have that uniform finish in there when you have that chatter and vibration. So as he was cutting, that part may not be 30 thousandths all the way up the part, but when we contrast it with the tool with the mirror edge and the ShrinkFIT holder, and we look at the next part, you'll visually see the step marks, but you won't have any of that chatter or vibration. And as you ring your finger up and down that wall, even though there's a visual line from the different passes that we took, you don't see the chatter or vibration. And that was cut at 140 inches per minute. Once again, that's a freestanding wall without any chatter. And if you flick the end of that part, you'll be able to hear the vibration and how thin that wall is in actuality.
Yeah, very thin wall, two completely different finishes here. Now, when it comes to that, is this what we should be expecting when it comes to finish?
Absolutely. Yeah, the part should be 30 thousandths thick all the way up, no deflection. A little bit of a pro tip, when you're cutting thin wall parts, you do actually want to leave a lot more material for that last pass. What that does is it keeps that wall nice and straight in front of you.
Well, very good. Well, very good. Well, hey, that was a good segment of our demo. We're going to keep things moving and moving on to the next. Hey, Aaron, what are we talking about next, man?
Yeah, so the next thing that we're going to talk about, Mike Enix is going to come back in, and we're going to move on to our Micron milling chucks. Mike, if you want to kind of give us a rundown on what we can expect from these types of holders when we get them into the machines.
Yeah, for sure. So Micron milling chucks have always been known for having really high gripping strength, and they're great for hogging or heavy metal removal, but they're not known for being very accurate. And with our Micron milling chucks, that's now changed. So these measure 2 microns at 3 times the diameter of the shank. So in terms of accuracy, they're extremely accurate. So I like to think of the Micron milling chucks as really a mechanical version of ShrinkFIT. You get all the benefits that you would with even the heavy wall ShrinkFIT in a Micron milling chuck, or our mold style chuck that you would with ShrinkFIT in terms of holding power, in terms of accuracy, and then with the mold style chuck, even with the small nose diameter, again allowing you to get down inside of pockets or in 5-axis machining. So the way we're able to accomplish that with the Micron milling chucks is most milling chucks use a needle bearing, and then there's a large nut that compresses the needle bearing cage in a milling chuck. The Micron chucks uses a ball screw mechanism and a sliding thrust ring. That eliminates a lot of the distortion that you would get as you thread down a nut of a regular milling chuck. So in terms of accuracy, there's really not a better milling chuck out there on the market. And I think you'll see this when we cut the heavy, the hardened material here, and you take a look at the accuracy. Actually, Isaac, could you show the run out video of the Micron chuck? I think we have some. Yep, here we go. So again, guaranteed to be 2/10 microns at 3 times the diameter of the tool. You look at that thing spin, it looks like the gauge is broken. So just extraordinarily accurate. You can see the small nose diameter, just like the profile of what you would get with a ShrinkFIT holder. So just a great tool holder. This is available in our Parlec brand, and excited to show this to you.
Now, when it comes to these Micron milling chucks, what are your thoughts on potentially over tightening? How do we handle that?
Good question, Eddie. Yeah, you cannot over tighten the Micron chucks. You actually just use an open-ended wrench, and you would tighten the chuck until it dead stops. So there's no risk of over tightening the holder. The larger chucks you can actually sleeve as well, I should mention. The Micron, the mold style chucks are going to be size on, but the Micron larger chucks can be sleeved.
Okay, so riddle me this. Why are we going to use a Micron milling chuck versus a ShrinkFIT? Tell me that.
So good question. You know, we have a lot of customers, Eddie, all the way from large production facilities to medium-sized job shops, even small job shops. Not everybody has taken the plunge into ShrinkFIT technology and invested into one of the machines that we saw earlier, but they still want the benefit of a really high-performance tool holder. And that's really where the Micron chucks comes in. So it's kind of a great substitute for ShrinkFIT. I call it a mechanical version of ShrinkFIT. So again, if shops just haven't adopted that technology yet, or they're maybe for whatever reason worried about introducing heat into the shop, that's really where the Micron chuck's going to play.
No, wonderful, wonderful. So obviously a lot of good information, some key differences here that we've highlighted. So as we continue to keep things rolling, Aaron, what's next for us?
Yeah, so we're going to take this Micron milling chuck, get it in the machine, and I have a file, a hardened steel, about 60 to 65 Rockwell file that we're going to machine here. And we're going to bring Mike from RobbJack back in to kind of give us a rundown of what tool we're using it and what we can expect with this type of tool in this type of holder. So Mike, if you want to come back in, I'll go ahead and get this cycle started, and you can kind of run us through kind of what we're looking at.
Thanks, Aaron. In this demonstration, like you said, this is going to be a 60 to 65 Rockwell hardened metal cutting file. We're going to be cutting it dry, and we're going to be machining this with the Micron milling chuck holder. That's kind of a typical die mold hard metal application where the tool is sticking out, pretty long projection. And even though that's 65 Rockwell material, you can hear how it cuts really nice. The sound is really good. That fireworks show that you're seeing is actually getting all the heat out into the chip. So we're cutting this, at 84 inches per minute, 10,000 RPM, and there will be no heat buildup in the part. It'll actually be cold when you're done cutting it. We have special geometries for the hard metal, so these tools last a really long time. And then we have special coatings that act as like a heat shield to the tool. So it forces all the heat out into the chip. And doing this trichordal type cutting in the hardened materials, it works awesome with the Micron milling chucks.
Yeah, great, great. And then here with that, we do have a finished part here. We're gonna get a close up on our close-up cam here to see what this looks like towards the end of the operation. We're gonna bring it down here, there we go. Wonderful, so here's what we're seeing. Now tell us a little bit about that finish. Is this what we should be expecting every single time, Mike?
Yeah, so it's hard because it's a file, so it has ridges all on it. So in certain angles you may see, and it may look like it's a bird edge or something like that. That's just the original ridges of that material that was used on the file. But it cuts really clean. You really can't tell anything wrong with the tool after you cut it. This is one of those examples where a lot of people are shocked to see this. You're able to cut a 65 Rockwell hardness material with a solid carbide end mill.
No, truly impressive, truly impressive. I think it's a great highlight and demonstration to see exactly what it was. Hey, and it was kind of cool seeing a little bit of sparks, right? Yeah. Usually it's not a good thing, but it was cool to see in this specific demo. So we appreciate that general insight as we keep this demonstration rolling. Aaron, what is next?
Yeah, so we're gonna move on to the Triton hydraulic chucks. And I believe we're gonna bring Brian back in to kind of give us the rundown on what we're gonna be looking at with this, this other type of holder that we're gonna showcase.
Yeah, awesome. I appreciate it, Aaron. Yeah, this is something that I'm extremely excited about. This Triton hydraulic holder is a phenomenal new tool that we just came out with the end of last year. We really started pushing it. I tell you what, if you can pull up that little bit of B-roll we have there on the internals of that unit, I can kind of speak a little bit to it here. So one thing, our new hydraulic holder has about 350% more holding power than the competition. Or than a standard, what I'm going to call a standard hydraulic holder. The reason being is it's a redesigned compact hydraulic system. It actually has some thicker bore walls to really help make it more rigid, and really helps us sturdy up that tool when we're in like a heavy milling application. Now, I know a lot of people just heard me say heavy milling and hydraulic in the same sentence. Sometimes that gets people a little heartburn. In the past, hydraulic holders have always been known for drilling and reaming. In our case here, we are able to do high efficiency milling and really pour the coals to that cutting tool when we're in a cut. All of these tools are going to be a standard DIN-B coolant through, as well as spindle coolant through. That's how they're going to come. And we offer these in all of your standard CAT, BT, and also HSK spindle options.
No, very good. So can you tell us a little about the holding power when you're using these reduction sleeves?
Yeah, so as Mike Enoch spoke to a little bit earlier about the TTG 594 coating that we do on the ShrinkFIT to make them what we call shrink locked, we can do the same style of treatment to a reduction sleeve. Now, anytime you are sleeving something down, you are stacking a tolerance. But as far as gripping strength, we are able to coat our sleeves with our patented formula, and it is going to give you about twice the holding power of any of our competition sleeves. So that is really it's really helping us to, again, get into that high efficiency milling and keep people good and confident in that they can pour the coals of that cutting tool and not have it twist and pull out.
Okay, so there's clearly some strength there. So tell me this, Brian, what about the ease of the tool change? How easy is that? How difficult is that?
Yeah, that's a great question. I'm glad you brought that up, Eddie. Actually, the ease of tool change here is simply a T-handle wrench like I'm holding here in my hand, and you can simply stop the spindle and not even have to remove your rotary tool holder out of your spindle. You can simply open the doors, get up to the tool, and change it right there with just a T-handle. And a good thing, this is very similar to the Micron milling chuck that Mike talked about the over-tightening aspect. This you cannot over-tighten. You don't have to worry about a torque setting for that set screw. You simply run the set screw all the way down into a positive stop, and then you're ready to rock.
Okay, well, right on, man. And one thing before we put this thing in the spindle and put it to action, I want to make sure, because I'm sure you probably have some non-believers out there, and I want to hit upon it one more time. Tell us about how really hydraulic trucks, again, they're known for the lighter applications, but you're really getting heavy with it. So how does that work?
Yeah, so it goes back to that redesigned compact design with that the heavier, thicker bore walls. That's going to allow us to get a little bit more engagement and a lot more pressure onto that shank, and it helps dampen everything in the cutting tool, and it's going to give that extreme hold, and something that people aren't used to. I mean, this is going back to everybody. When you hear hydraulic, it's either very, very light finish milling and profile milling, or drilling and reaming. Nobody wanted to do anything else with them. So in the new Triton line, that's why I'm so excited about this. It's making non-believers believers. We just got to get them to try it. And if you, like Mike said earlier with the Micron, if you don't want to make that investment out of the gate with the hydraulic holder, or I'm sorry, with the ShrinkFIT machine, you have a great option, the hydraulic holder, that's going to hold that good tolerance and great ease of tool change.
There you go, making some believers today. That's what I'm all about, man. So that's good stuff. And then with that, now we've got a little bit of an understanding of the Triton hydraulic chucks. What are we looking at next at the spindle?
Yeah, so we got another RobbJack tool in our hydraulic holder, and I'm gonna get the cycle started here in just a second. Mike from RobbJack, if you wanna come back in, kind of give us a rundown on what tool we're running and how it incorporates with the hydraulic chuck we're gonna run, and how we're able to machine the part that we're getting ready to look at.
Awesome, thanks Aaron. So this demonstration is going to show how you can quickly remove a lot of aluminum on your machine in a single depth. So this tool is going to take a 2 times diameter depth of cut in a single pass without chatter, has the mirror edge. This is our A1 303 series. And really the only limiting factor is going to be the max RPM and horsepower of your machine. With the added gripping force from the Triton hydraulic holder and the chatter reduction geometry, you're really making sure that you're going to have success. The one thing you want to do is listen as it's cutting. As it stops and changes directions, listen to the cut. You don't hear that squeal and squawk as you go into all the corners. And we kind of designed this case, this sample part, for like worst case scenario. We designed it with really acute angles into internal pockets. We designed it to come really far from the outside to the inside, creating thin walls. And so this really is not that demo part that's designed to optimize the tool. It's really a demo part to really show what the tool can do in a worst case scenario. The other thing is we're doing 50% step overs with the tool. 50% step over usually gives you the most vibration and the worst finish. So we're doing everything at the worst case, and we're doing it at 212 inches per minute, 10,000 RPM, which is, we're limited for the machine, only has 10,000. So if you add more, you can use a lot more and go a lot faster. But in this part, we're going 10,000 RPM, 212, and 2 times the diameter in the single pass. So, which is about 30 cubic inches per minute removal rate. So as the part finishes up and we do this cutting, we'll go ahead and listen to it, and we'll be able to look at the finishes and everything on this finished part.
Now, as we wait for it to make some of these final passes here, Mike, tell us, we're seeing it run through aluminum. Would this type of tool perform really well in other materials as well?
We have tools specifically designed for like titaniums, stainless steels. It would not be this same tool. The mirror edge geometry that we have on this tool can be used in like where you have chatter in other parts, but really these tools are designed to be optimized for their specific applications. And this one is an aluminum specific tool.
Wonderful, wonderful. Well, hey, no, that's good insight. So we've been talking about it. Let's see the finish that we're looking at here. And so as we're looking at it, you're seeing thin walls, but who needs to hear it from me, Mike? Give us the good insight here.
So as Aaron rotates that and we look at it, you can see how reflected those finishes are on the part. That's a 4-inch by 4-inch block. It was a solid block before we started. We did those 3 internal pockets. We helically bored them, and then used a dynamic tool path to do those pockets. And you can see the really good finish. And what you want to really concentrate on is that acute pocket, that angle in that one bottom pocket right next to like your thumb area. And that is usually a problem area. and you'll get barber pulling and the tool pulling into the part. But, you know, you just see really nice finishes on that part. And that was done at full depth in a single pass with our A1 303 series.
Yeah, it looks beautiful, beautiful, man. So is this the typical type of finish that we would expect every single time from this tool?
Absolutely. If you're not getting that finish, sometimes people will actually be too conservative and actually be going too slow. And that's usually where you'll run into problems. With these types of tools, you don't have to slow down the RPM. You just go as fast as your machine can go and uses max RPM. It makes it easy on the programming. So that is the typical finish.
No, very, very good and impressive nonetheless, being able to see the capabilities, the finish, those thin walls. This impressive all around. So we thank you so much for that general insight. And so for everybody, that concludes the demo portion of this event today. So what we're gonna do is we're gonna bring in each and every individual on for one more quick recap of the segments and their final words. So we're gonna start here by bringing back on Mike MacArthur from RobbJack. So hey man, we know you just got done talking about all these amazing tools. Give us a quick recap on what we covered today.
Thanks, Eddie. To get the highest performance out of your machine, it's just real important to think about it as a whole system. It's important to think about what cutting tools you're going to use, what tool holders optimized for the application. And then if anyone needs any assistance in their cutting tool applications, be sure to reach out to myself or anyone on the RobbJack team. And we're always there to help you out and improve your machining applications. Thanks a lot.
Always there to help you out. That's wonderful. Hey, thank you so much for the insight that you've provided. You brought an immense amount of value talking about these tools, so we appreciate you. Thank you so much for joining us. Next, we're going to bring on our man Brian. Brian, hop on back up here, man, and give us some of the final recap insight on what you covered with us today.
You know, first off, I just want to thank you and Aaron and the whole Flex team for helping us make this an actual big success and really fun. So I want to thank you guys for that first off. When it comes to the two items that I kind of highlighted here, any more questions or concerns you have on any of the hydraulic stuff or anything that we've looked throughout this video of the Techniks or Parlec, feel free to reach out. You can visit either one of the websites. You have TechniksUSA.com as well as Parlec.com. You can call either one of the 800 numbers at Parlec or Techniks. You'll be able to get a very knowledgeable inside person that can help answer any of your questions you need. So again, thank you for that, and that's kind of my sign off, and I appreciate you guys.
Hey, we appreciate you and all your passion and expertise that you brought to this demo today. Very, very thankful, so we appreciate it. And last, hey, but certainly not least, we're going to bring in the final member from the Techniks team, Mike Enix. Hey, Mike, hop on back here. You know the drill. Give us a recap of what we've covered today.
Yeah, thanks, Eddie. I want to just thank all the viewers for tuning in. I want to thank Mike MacArthur for his participation. So he stole my thunder a little bit, because I was going to say that really, you know, as a tool holder specific company, we talk all the time about the importance of making sure that not only is the machine, you know, the right equipment for the job, that you're utilizing the right cutting tool, but you're also not only using a high quality tool holder, but the right tool holder for the application. So really it's a symphony of those three things to optimize your cutting performance. So that's kind of what we saw today is really the marriage of a good cutting tool, a great tool holding system, and optimized cutting results as a result of that. So thank you guys for all your work on this. Appreciate it.
Man, we appreciate you as well for all of your industry-leading insight that you've provided today. And so the last opinion that we always love to get is that of the true machinist, the man who's hitting cycle start, making it all happen. Aaron, you got to play with all these toys. Give us your thoughts and opinions on what we were able to experience today.
Yeah, so everything that we saw today, just like both Mikes kind of talked about, it really is a marriage of having the right cutting tool with the right tool holder. So being able to see that, I mean, we saw cutting a 30 thou thick wall with no chatter. It's almost unheard of. So being able to have the right tool and the right tool holder. But also I want to kind of touch on the ShrinkFIT machine. Super easy to use. So kind of like what Brian has talked about, you know, if somebody hasn't bought into that, knowing that you can, I literally learned this machine in a matter of 10 to 15 minutes on the phone with Brian, which thank you, by the way. But being able to learn it so quickly, it's so easy to use, and being able to put out awesome parts. All these products were great. I want to thank both RobbJack and Techniks for letting us kind of play with everything, see the new technology and how it works, and it was a lot of fun.
There we go. Hey, well, I appreciate you, man, because Lord knows if I was hitting CycleStar, I would break everything. So we not only thank you, Aaron, we thank all of you viewers for joining us and our 3 industry leading experts. We hope all you viewers at home were able to find some good ways to not only maximize your capability, but turbocharge your machining. So we thank you so much for joining us. Make sure following our demo, you head on over to Techniks YouTube page. I need you to hit that subscribe button, ring the bell to turn on the notifications, and give us a huge thumbs up. This is Eddie. This is my man, Aaron. We thank you all. You all stay awesome. We'll see you next time.